let's finish this up. So I wrote down that the original functions were 2 over x, g of x is x minus 1. So let's go ahead and find f of g of x, which is actually, I like this notation a little better, f of g of x, right? So let's go f of, and then you say, well, what is g of x here? What is g of x? Let's punch that in here. X minus 1. So now x minus 1 is the input into f. So let's write f. So you know how f is 2 over x? 2 over x, and I like to put a big parenthesis there for my x. 2 over x, right? But what am I plugging in for x? I'm plugging in x minus 1, right? X minus 1 right there. You know what? I'll put it in green. Keep this color coordinated for you. Okay? So f of g of x is 2 over x minus 1. Okay? And our domain here is the domain of g such that g is in the domain of f. Okay? So if you want to look at this thing, simply put, you know how this bottom x minus 1 cannot be 0, right? Well, what causes this? What x value causes the denominator to be 0? Well, 1. Okay, so your domain here is x can be anything I want, so it's an element of the real numbers, except I cannot be 1. That's the only restriction that I have for f of g of x. Okay, let's do another one now. Let's do, how about g of f of x? Let's go the other way around. G of f of x. In other words, g of f of x. There's the other notation. And I say, okay, now my input is f of x. Right, my input is f of x, so that 2 over x. Alright, so f of x is 2 over x. So now I'm inputting 2 over x into g. So let me write my g function. My g is x minus 1, right? I believe that big space. But what am I plugging in for x into that x minus 1 function? My input is what? 2 over x. X minus 1, right? So there it is. 2 over x minus 1. So that is g of f of x is 2 over x minus 1. And our domain here is the domain of f. Okay, the domain of x was, and think about it, you can think about it right there, right? What can x not be? Well, if I input 0 right there, I'm going to have an issue, right? Can't divide by 0, 2 over 0. So it's anything except 0. That's my only problem here. So the domain here, anything except 0. Okay, all real numbers except 0. Let's do some more. Okay, f of x was 2 over x, right? And I think g of x was x minus 1. Let's go ahead and find f of x. So this is part C. So how about f of x? Okay. So say, okay, let me give you that other notation as well, in case you see that. F of x, which is again the same thing as f of x. Okay, we say, well, what's f of x? What's f of x? 2 over x, right? Now I'm inputting 2 over x into f, right? So I say, well, what was f? F was 2 over x, right? But what am I inputting into there? I'm inputting 2 over x into there. Okay, so that's f of x. Now I got to clean this up a bit, right? This will simplify, but right here I want to look at the domain as well. Notice that 2 over x. X cannot be 0, so I know right away x cannot be 0 for this thing, okay? And look what happens when I go ahead and simplify this. So I got 2 times x over 2, right, my numerator up there. See how I got x over 1? So my f of x simplifies to be x, but we know um, we had that restriction. We know that the domain could not be 0, right? Which we wouldn't have known that if we hadn't looked, right here when we did the composition there. If you didn't think about the domain of f prior to simplifying this thing. Okay, so that's our domain. Okay, let's do one last one here. Okay, one last one. How about g of x? Okay, so I say, well, then g of x is x minus 1, and now I'm running the input x minus 1 into g. What is g? X minus 1. X minus 1. And what am I putting in there? I'm putting in x minus 1. So I got x minus 1 minus 1, or x minus 2. So there's g of x is x minus 2. I have no restrictions on this thing. And thank you. We'll see you in class.